Hello and welcome to Tribe Topper. In this video session, you are going to learn about power, current and potential difference. So what is power? Power is defined as the rate of doing work or rate of transfer of electric energy, and the SI unit is watt. See, you might have seen many times the electrical equipments in your home, all the electrical appliances, they have a power rating, like they say 1000 watt or 2000 watts. What does that mean? It is telling you that how much electrical energy they are going to consume in an hour or per second. So power is defined as work over time, that is how fast work is done, or we can also say it's the rate of consumption of the electrical energy. So E by T also goes for it. Now here, because we just learned about current and potential difference in the previous sessions, we know that voltage, the potential difference, is defined as the work done per unit charge. Therefore, this gives us that work is equal to Q times V. Now, we will replace this QV here in the expression of power. Therefore, we get what? That power, which is work over time, can be written as Q times V upon T. And by the definition of current, we'll say since I, it's the rate of flow of charge, that's Q by T. We have done that in the previous sessions. Therefore, power, this Q by T can be written as I. So power is equal to VI. This is a very, very important relation that exists between the power, current and the potential difference. And when I say the SI unit of power is 1 watt, so 1 watt refers to 1 joule of consumption of electrical energy in 1 second. And there are some bigger units of power. We use 10 to the power 3 watts as kilowatt and 10 to the power 6 watts as megawatt. So let's have a look at this question, which says that a 3 volt 1.5 watt filament lamp is connected to a 3 volt battery. Calculate the current in the lamp. So this is a direct question. If you try to look at the question carefully, what is given to you? The power rating is 1.5 watt and it is operating on a 3 volt battery. We want to find the current in the lamp, and we just did the expression that P is equal to VI. Therefore, what is I equal to? That's P upon V. So that's 1.5 divided by 3, which gives you 0.5 amperes of current. In the B part, they ask you, what is the energy transferred in 2400 seconds? See, when they say the power is 1.5 watt, what does that recommend or suggests? This suggests that the energy consumption is 1.5 joules in 1 second. So we'll say in 1 second, the energy consumption or energy transferred is equal to 1.5 joules, because 1.5 watt power means 1.5 joules per second. So in 1 second, energy transferred is 1.5 joules. Therefore, in 2400 seconds, the energy transferred would be 1.5 times 2400, which gives me 3600 joules of energy is transferred in 2400 seconds. That's all in this video session. In the next video session, you are going to learn about the Kirchhoff's laws.